David Spieth here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Okay, I want to explain the problem, the homework that we did from page 253, which is called Instant of Impact. This brings together the whole concept, our whole methodology for finding an instantaneous rate. Okay? So the situation is a helicopter is above the ground, it's 400 feet above the ground, and they drop a supply bundle, and we watch average speed at various points in time as that bundle falls to the ground. Okay? So we know from an earlier activity that it hits the ground at 5 seconds. That's the time at which it hits the ground. That's just setting this equal to 0 and solving for t. So we've done that already. So question 1 had us figure out how high it was at 3 seconds. So we plugged in 3 seconds for t, and we solved that, and it ends up that at 3 seconds, it's 256 feet above the ground. So 1b was, what is the average speed during that last 2 seconds, from 3 seconds to 5 seconds? So what we do is we just take the number it has to fall in that time, and we know that if it's 256 above the ground, it's going to fall 256 to get to the ground. And then we know that this is at 3 seconds, the ground is at 5 seconds, so it takes 2 seconds to get there. So the average speed for the last 2 seconds is just 256 divided by 2, which is 128 feet per second. So during that time, during that last 2 seconds, it averages 128 feet per second. The speed is constantly changing during that time. So this is an average. It's not actually a speed at any exact moment along that way. So I'm going to track these answers up here. From 3 to 5 seconds, we're going at an average of 128 feet per second. Okay, question 2 was having us calculate the average speed for the last second of the fall. So that's from second 4 to second 5. So what we did, the first step, 2a, was what is the height at the 4th second? So you plug 4 into the equation, and that spits out 144 feet. So it's fallen for 1 more second, and now it's only 140 feet above the ground. 2b is calculate the average speed during that last second. Now this calculation is pretty easy because it's over 1. So it fell 144 feet in 1 second, so that's 144 feet per second. So I put that up here as well. So now from seconds 4 to 5, it's averaging 144 feet per second. And that makes sense because we're picking a time over which to calculate our average where the object is just falling faster. Okay. Question 3 didn't break it up into A and B. Question 3 just simply said, what is the average speed during the last half second of the fall? And they're leaving it to you to break it up into those A and B steps, which are both necessary to get the answer to this problem. So let's take a look. At height of 4.5 seconds, we plug 4.5 in for t in our function, and if you do this math, you're going to get 76 feet. So after 4.5 seconds of falling, it's now only 76 feet above the ground. So now to find the average speed, we divide the distance it has to travel by the amount of time it travels that distance. So 76 divided by 0.5 ends up being 152 feet per second. And again, this makes sense. It's falling that last half second, so it's going even faster than during the last second. So over here, I added that to our list. 4.5 to 5 seconds. Now in that interval, we are falling at 152 feet per second. It's still an average speed. We still don't have our instantaneous speed, but we're getting pretty close. Okay, so question 4 wanted to know what's the average speed over the last 1/10 of a second. So what we're doing, we first need to find the height. This is question 4. We need to find the height at the last 1/10 of a second. So that's after 4.9 seconds have passed. And so we just plug our 4.9 in for t, do the math. This ends up being 15.84 feet. Okay? So now to find the average speed during that time, we need the distance fallen divided by the time taken. So the distance fallen is 15.84 feet because that's how high it is above the ground. It's going to fall that distance before it hits. And then we're going to divide it by 0.1 second. right? That's the distance, the time it takes to fall. This is an easy division to do in your head. Just move the decimal place one to the right. This is 158.4 feet per second. So it makes sense. Now that we went from the last half second, which is 152, to the last 10th second, the average is 158.4. So let's add that to our list. 4.9 to 5 gives us 158.4 feet per second. Okay, question 5 requires the conceptual leap. Question 5 asks, what is the instantaneous or exact rate of the bundle when it hits the ground? So this progression has been leading us to this question. What we're going to do is we're going to calculate the average rate of speed for a very small piece of time that ends at the time of impact. So you can see the progression. This was 2 seconds to impact. This was 1 second to impact. This is half a second to impact. This is 1/10 of a second to impact. So you might already be looking at this and kind of get a feel for where we're going to go. But if you're not sure, then let's take a really small number. So this is the last 1,000th of a second before impact. Practically there. But we're going to calculate the average speed between 1,000th of a second before impact and impact. Okay? So what I did is I put in 4.999, that's our time, into our height function. And that tells us that at that point the object is 0.1599 feet above the ground. So it's like right about there, but not yet. It's still moving quite quickly. So what we need is the change in height. To get our rate, we need the change in height. So that is just this. It's going to go from this number to 0. So this is 0.1599 feet. And we need to divide the distance traveled by the time spent traveling that distance. And this is 1,000th of a second. Oops. That's weird. 1,000th of a second is written like that, okay? Now this division is also pretty easy. It's dividing by 1, but move the decimal places 3 to the right. So we're going to get 159.9 feet per second. So that's not quite the answer. Pause the video for a sec, think about it. What is the speed at the exact moment it hits the ground? Okay, if you said 160, you're right. This points at 160 feet per second. And you can tell that by the progression. 128, 144, 152, 158, 159.9, 160. And my guess is that if you wanted to add some 9s to this and divide by more decimal places, you would get 159.9999. Eventually, your calculator will round that to 160. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like. And if you'd like to help me grow my YouTube channel, please click subscribe.